Now, this is the third part of our topic under sound wave, and it will be based on question, solving of question under sound wave. So the first question says, a source of sound produces wave in the air of wavelength 1.65 meter. If the speed of sound in air is 330 meter per second, the period of vibration is dash. It's very simple. In the question, if you look at it very well, we have this information. They gave us wavelength. So wavelength is called 1.65 meter. Then they gave us the speed. The speed is equal to 330 meter per second. So we are looking for period. What we just need to do, once you get frequency, you get the period. So now go to formula that connect frequency, speed, and wavelength together. And the formula is V is equal to F lambda. Then from here, make this frequency the subject of formula. So frequency is equal to V over lambda, which is equal to V330 divided by what? 1.68. So this one will give you 200 Hertz. That's all. Then we have gotten the frequency. Now go to the what? Period. Period T is equal to 1 over F. Therefore, period is equal to 1 over 200, which is equal to 0.005 seconds. 0.005 seconds. Now the second question. The question says a string of mass 8 grams and length 20 centimeter. So we have mass is equal to 8 grams. So convert it immediately to kilogram, which will give you 0.008 kilogram. Then length in the question, if you look at it, the length is 20 centimeter. The length given L is equal to 20 centimeter and it's equal to 0.2 meter. Then from the question, they gave us the tension. Look at it. The T is equal to 160 Newton. Then we are looking for frequency. We are looking for frequency of the first overtone. You can get frequency of first overtone. What you do is that find fundamental frequency first. And don't forget the formula that connects fundamental frequency with tension and mass. So in that case, we are going to use F naught is equal to 1 over 2L square root of T over L. And don't forget, this our L, you have to divide it by what? By this one first. So therefore we have our F naught is equal to 1 over 2 multiplied by what is the length? The length is 0.2. Then multiply by square root of tension, that is 160. Then divide by mass. This mass, don't use this mass, you divide it by what? 0.2 force. So 0.008 divided by 0.2 will give you 0.04. So this one will be 0.04. By the time you press your calculator, so you are going to get 158.1 what? Hertz. That's all. And this is our what? Fundamental. This is fundamental frequency. And don't forget, it's a string that contain all harmonic. So we are looking for frequency of the first overtone. And the first overtone is same thing as what? Second harmonic. So what you just need to do, multiply this one by 2. Therefore, our F2 is equal to 2 multiplied by 158.1 Hertz. So whatever you get is your final answer under that. So another question says, if the shortest wavelength of the tube for resonance is 0.1 meter and the next resonance length is 0.35 meter, what is the frequencies of the vibration if the speed of sound in air is 340 meter per second? Then compute the wavelength. So in that case, from the question, they give us L1 is equal to 0.1 and L2 is equal to 0.35. Then from the question, they gave us the speed 340. Then V is equal to 340 meter per second. So we are looking for the frequency. So we now use V is equal to 2F open bracket L2 minus L1. If you look at the question very well, so we have this one, 340 is equal to 2F open bracket is 0.35 minus 0.1. So it will give you 340 is equal to 2F open bracket 0.25. Therefore, 340 is equal to 2 times this one will give you 0.5 F. Then divide both sides by 0.5. Therefore, our frequency will be 340 divided by 0.5. Your answer will be 680 R. Then the next question says compute the wavelength. No problem, just go to the formula that relates. Since we have velocity and we have gotten what frequency, just go back to say V is equal to F lambda. So we are looking for this one. Therefore, lambda is equal to V over what? F. What is our V? Our V is 340. Then our F is what we just got, 680. So it will give you 0.5 meter. 0.5 meter. Now, another question says the shortest length of a column in a closed tube. This one is closed pipe, which resonates to a frequencies of 600 Hz is 400 centimeter. What is the wavelength of the sound in here? And determine the velocity of the sound. So from the question, they gave us the frequency is given. Frequency is equal to 600 Hz. N is equal to 400 centimeter. Convert to meter immediately. Therefore, this one will give you 4 meter. Then don't forget, this is a closed pipe. For closed pipe, we have N is equal to lambda over 4. We are looking for this lambda. Therefore, our lambda is equal to 4L. So which is equal to 4 multiplied by, what is the L? L is equal to 4. So our lambda is equal to 16 meter. Then the last question under it says N. Determine the velocity of the sound. Then go back to formula. V is equal to F lambda. So therefore V is equal to, what is F? They gave us F directly, 600 multiplied by what? Lambda. What's our lambda? We got lambda to be 16. Then you multiply it. Whatever you get is your answer, and it will be in meter per second. Very simple. So that is the end of the